Welcome everyone. Welcome to another episode of Coding Talks. Myself Vishnu Viji. This podcast is available on all podcast platforms including Spotify, Apple Music, Amazon Music. It is also available on YouTube. You can check out my YouTube channel Coding Talks with Vishnu Viji, and also the verbatim transcription of this podcast will also be available on my LinkedIn as well as on AWS Community Builder blog. Feel free to check out from whatever platform you're interested in, and thanks for tuning into Coding Talks. Today in the episode, I like to discuss about the Amazon Sagemaker, which is an AI service available within AWS for creating custom AI models. If you are wondering about how to actually implement AI in your organization, you are in the right place. We are exploring the platform that make machine language or machine learning as well as AI models accessible to everyone, not only for data scientists, but for others, including the business analyst as well. When we see the generative AI applications, whether it is ChatGPT or whatever kind of applications that use some form of an AI or an underlying foundation model, what we see on the surface, like those impressive chatbots, image generators, they all represent just a tiny fraction of what's needed. The real work behind all those chatbots and the different image generators happen beneath the surface. A lot of work is going on, like organizing the data, building models, ensuring security, and managing everything at scale. And if you are facing such challenges in all those areas which we discussed, like organizing, building models, development of models, or securing the developed models, or to deploy those models to make it available for the general public, Sagemaker handles all of this complexity for you. It is like having a complete AI team in the cloud, which help you to build, train, and deploy machine learning models and AI models without needing a deep understanding of these. So you don't need a PhD in data science to work on these models using Amazon Sagemaker. Sagemaker makes all these things very easier for you. So by the end of this episode, you will understand how Amazon Sagemaker works. We see some of the real examples of organizations using it successfully, and also give you pointers on where can you start or how to get started with your own AI products. There are a lot of services within the AWS, especially when it is related to the machine learning or whether it is for the generative AI. Lot of services you can find, and out of that, 3 major services are: one is the Amazon SageMaker, another one is Amazon Bedrock, and also an agent runtime or agent core runtime is also available. So before we dive deep into SageMaker, let's quickly clarify when you would choose each of these AI service. It's like choosing the right tool for the job. So we can start with the Amazon Bedrock. If you are interested in building chatbots, content generation, or applications using foundation models like Cloud or GPT or Gemini, and lot of other models as well. This Amazon Bedrock provides ready-to-use foundation models. Basically, it provides an API by which you can connect with these models and do inferencing on behalf of these models. It is as simple as that. Rest of the works, everything hosting these models, its scaling, all will be handled by Amazon Bedrock. So Bedrock is perfect for rapid prototyping and applications that don't require deep custom model training and all. In addition to that, Bedrock has a lot of other features as well. This is not a specific episode on Bedrock, so we are not going deep into that. Basically, the idea is if you want to have some generative AI features in your application, existing application, Bedrock offers an API where you can interact with any of these foundation models. You can on the fly change models. You can add your custom organization context or data on top of that model. So everything can be built very easily using the Amazon Bedrock. So in that case, the custom model training is not required. So that is why we are going ahead with the Amazon Bedrock service. Similar way, there is another tool which is available in AWS, which is called the Amazon Q Developer. You can find that as a kind of a CLI tool whereby you can interact with Amazon Q. It offers a lot of guidance on how you can develop applications using AWS. The entire documentation is fed into the Amazon Q so that it offers the best guidance on building applications using AWS. Also, Amazon Q has a different mode called agent mode that can help you to reason, plan, and take actions. It can assist with your AI development, coding, correction, and all. So you can install this Amazon Q into your existing IDE like VS Code. It's also integrated within the AWS console, so you can interact using that way. Or it's also available as a standalone CLI. You can install on your Windows, Mac, or Linux machines. Authenticate it using your AWS Builder account, and then you can connect and take advantage of Amazon Q Developer. So it's kind of an agentic AI assistant which helps with coding and kind of a consulting with the Amazon Q to understand the best practices, especially for the Amazon ecosystem, AWS ecosystem. Then one more service is there, which is called the Agent Core Runtime. And this is useful for hosting and deploying the agentic AI applications. Agentic AI applications are capable of understanding your requirements. It can plan and create different tasks that work in parallel to make those instructions execute. And then in addition to that, in addition to this planning, executing the task, it also has a feedback mechanism by which it iteratively improve each of these tasks so that until your whatever you mentioned on that prompt get achieved, it will continuously reiteratively improve the tasks. So that's the core idea of agentic AI applications, and multiple such agents can work in parallel together to achieve certain goals. Goals in the sense like organizational workflows or to satisfy some business requirements or whatever. Previously, the focus was mainly on the generative AI which can generate the conduct of contents on behalf of you. And second thing is nowadays which is getting popular is the agentic AI, where multiple agentic AIs can work together in such a way that it can achieve certain business goals. So these are two services that we discussed before going deep into the Amazon Sagemaker. Now coming to the Amazon Sagemaker is your complete machine learning platform for building custom AI tools. Organizations choose Sagemaker when they need to train models on specific data. Also, whenever they want to build custom algorithms for solving their unique business problem, they rely on a Sagemaker. Then experimentation of enterprise products, and also when they want the full control over their machine language or AI pipeline, they need Sagemaker. So you can think of Sagemaker like as a tool which is useful for developing deep custom models which cannot be provided by either the Amazon Bedrock or the other services. But the effort will be a little bit more than that. In the case of Amazon Bedrock, you can connect your applications to Amazon Bedrock through an API, and you can choose a model, foundation model, and you can use directly. Whereas in Sagemaker, you have the responsibility to train the model, improve the model, deploy the model. But Amazon can help with like a complete box, a toolbox for supporting all those activities. So that's why it's called a complete machine language platform. So once again, we understand more about these three services before we go deep into the episode. Bedrock is the best service when you want to get started with some kind of a pre-built AI foundation model. Also, the agent runtime can help you to create complex reasoning workflows. Agent AI runtime, actually, it's a kind of an environment. Basically, you will be creating agentic AI applications using some kind of a framework like a Stance AI or some other tools, frameworks which helps with agentic AI. Agent runtime actually helps you to deploy those agentic AI applications which you developed. It provides a complete platform for that. Then coming to the Sagemaker gives you the power to build exactly what your business needs. It depends on the organization. Some of the organizations will use all these three services together. Bedrock for getting started or like a quick wins, agentic AI and agent core runtime for developing intelligent automation, and Sagemaker for getting a competitive differentiation through some custom AI. So it's the most advanced case. So this thing has to be keep in mind, and this is one of the things confuses many developers, because lots of services, overlapping services are available within the AWS, especially when it comes to machine language, machine learning, and the generative AI. So the easiest way to understand this is that Sagemaker is suitable for when you want organizations want a competitive differentiation and to develop some custom AI models which the other services cannot offer. And what kind of industries that can benefit from this kind of service like Sagemaker? Lot of services, lot of organizations are actually leveraging Sagemaker. If we took some data, financial services leverage Sagemaker for fraud detection and risk modeling with proprietary data. Similarly, healthcare organization use it for their drug discovery research and also for analysis of medical imaging under strict compliance requirements. Also, other fields, other domains like manufacturing companies deploy predictive maintenance and quality control models using Sagemaker. Then coming to the e-commerce domain and retail domain, many organizations are using Sagemaker to build personalized recommendation engines and the demand forecasting systems. So what makes this Sagemaker special is that it provides a complete all-in-one AI workshop. That means you will be getting a complete AI workshop where everything you need is in one place, which is called the Amazon Sagemaker Unified Studio. You can log into AWS console and search for Amazon Sagemaker, and that lands you in the Amazon Sagemaker Unified Studio. Here you will get multiple tools that help with your custom AI and machine learning application development. Instead of confusing with multiple tools, switching between different platforms and trying to make everything work together, you get one integrated environment called Amazon Sagemaker Unified Studio. It is like having a well-organized workshop where all your tools are exactly where you need them actually. And behind the scenes, Sagemaker handles the complex steps automatically, like data processing, model training, deployment. It all works together seamlessly. You will be focusing on solving business problems, and managing infrastructure and scalability all will be handled by AWS. So there is why the Sagemaker really shines. You will get a good team collaboration because in Sagemaker, everything revolves around the concept called projects, which you can think of as kind of a shared workspaces where your entire teams can collaborate. Multiple teams can create multiple projects and everything can be interconnected as well. So that means whoever who will be involving in this kind of a AI custom model development for an organization, that can involve data scientists, engineers, and business analysts, developers. They can all work together in the same environment. So that means that these teams don't have to send more emails or chats between each other, sharing the model files or to discuss about which version is the best. Everything will be consolidated and tracked within the Sagemaker itself. In addition to that, like we discussed before, Amazon Q Developer acts like an AI pair programmer, helping your team write better code faster and explaining complex concept of AWS in simple terms. And also to help with developing your AI model, Sagemaker comes with over 15 pre-built algorithms. So you don't have to start everything from zero. You don't have to import your algorithms into Sagemaker. Everything will be available within the Sagemaker. And you will be getting a kind of a toolbox full of specialized AI tools ready to use. So a lot of tools are available. We cannot go too much deep into all of this in this podcast, but if you think about some of the category like business intelligence, visual recognition, text and language processing or forecasting, different kinds of algorithms are available. So what this matters is that, why this matters is that instead of spending months developing algorithms, you can have a working AI model in Sagemaker within a few days or within a few hours. And these are actually enterprise-grade algorithms, tried, tested enterprise-grade algorithm that can handle data sets from gigabytes to petabytes And these are already used by companies like Netflix and Airbnb in production. So you can trust those models as well. So most of the time, organization, once they get into the Amazon SageMaker Unified Studio, they will start with these proven algorithms, then customize as their needs grow. So it's like learning to cook with tested recipes before creating your own dishes. So some of the main categories like business intelligence, there are tools like XGBoost, which are available for fraud detection. Similarly, for predictions, there is a algorithm called linear learner is available. For customer segmentation, K-means is available. Also, when it comes to visual recognition, different algorithms are available for image classification. Basically, image classification, one of the use cases is content moderation. Then object detection models are available for inventory as well as for medical image analysis and other cases as well. Similarly, based on the textual data, we can done an analysis of the sentiments, also can convert a language into a different one, then document topic discovery. These are text and language related services. These are also available. Similarly, for e-commerce organizations which needs forecasting, like on-demand planning, sales predictions, or banks which require anomaly detections or credit card fraudulent activities, or for system monitoring. So different algorithms are available within the SageMaker Studio itself. So that means organization will be starting working on this. Now, looking into the detail of what kind of tool sets that are available within the SageMaker Studio, you can think of these like different workbenches in your AA workshop. Different teams will be using different workbench. Let's start with the easiest one, which is the Data Explorer, which is the first step. So here we find the actual information which is required for developing the model. So here in the Data Explorer, you can connect to different connectors. Connectors in the sense like you can connect to wherever your information lives. It can be sometimes in databases, sometimes the information might resides in a data lakes or S3 buckets. The beauty of this Data Explorer or the query editor, which is available within the Amazon SageMaker Studio, is that it acts like it's like a universal translator for your data. So it doesn't matter where your information lives. You can have it in different area and different connectors are available. So all can access it through one simple interface. That means you don't have to switch between different tools or learning multiple query languages to understand and collect those data. Using connectors, you can connect and with a simple plain SQL, you can access the data or ask questions about the data. And the SageMaker platform actually handles the complexity behind the scenes. Now, once the data is available, then the next step is to work on the notebook. So here is where your experimentation starts. These notebooks are kind of an interactive documents where you can write code, see the results immediately. You can write some codes and you can run it immediately by line and document all your thinking all in one place. For this, you can use Python, SQL, or any languages depending on what you are actually comfortable working with. The underlying platform automatically handles the computing power you need, scaling up for big jobs and scaling down to save cost. And once the notebook, multiple documents are done, you can connect that through a seamless workflow. Everything connects automatically. Your data exploration feeds directly into the model building. Your experiments become production model within just a few flicks. So that means you don't have to copy files between systems or recreating work. your entire AI pipeline flows smoothly from start to finish. Pipeline in the sense workflow. And for starting this, organization don't require a complete infrastructure overhaul or anything. AWS provides multiple pathways to begin with. Whether you are starting first experimenting with ML model or an enterprise, already they or in the enterprises they already having some form of an existing platform, they can migrate as well. Also, for trying this out, AWS provides a free tier that includes Sagemaker Studio Labs, allowing you to explore machine learning capabilities, and also organizations that are ready to scale. SageMaker offers a kind of a pay-as-you-go pricing. With no upfront commitments, you only pay for the compute, storage, and the data processing you actually use. Similarly, when multiple teams will be working on this kind of a Amazon SageMaker Studio in a unified way. So this is one thing I want to stress. So multiple teams will be working here. So in the ideal case, what happens is like even though multiple teams were working together, it's completely considered as a kind of an unified environment. And also, in addition to that, whenever organization starts working on this kind of a unified platforms, certainly there requires some kind of a skill development and migration efforts. Most of them are already documented in the AWS documentation. But if you need, AWS also provides different tools and professional services to help transition from existing ML platforms. Also, those of you who listening, if listening first time these episodes, there will be a training and certification program also available specific to different types of roles like a data scientist, ML engineers, or business leaders. Those are all available from AWS training and certification program. And there is a platform called Skill Builder which can help you to quickly speed up with these different areas. Also, specialized AWS solution architects are also available to design custom implementation and strategies tailored to the different organization specific needs. And SageMaker is actually built for business critical applications. Your data and the models that you develop are protected by the same enterprise-grade security that Amazon's own operation, that powers Amazon's own operation. 3 security pillars are automatic protection through data encryption, network isolation, and access controlled by default. Then the compliance is ready, like it meets the certain compliance standards like a HIPAA, GDPR, SOC, and PCI DSS requirements out of the box. And also, when multiple teams work within the SageMaker Studio, every action is logged and traceable for audit requirements as well. And the governance models are made simple. Built-in model lineage tracking means you can trace every model from raw data to production deployment. And also bias detection and explainability tools help ensure a responsible AI deployment as well. So the bottom line is that SageMaker handles security complexity so your teams can focus on building great AI solutions and not managing about these compliance checklist and governance requirements. Everything comes out of the box as well. And the return of investments that organization get from the Amazon SageMaker is it can have a measurable financial impact, like a 25 to 40% cost reduction. If by comparing that with if you build your own ML infrastructure, you would need more cost actually. So around 25 to 40% cost reduction you can expect in this. And also during the model training, especially when you collect the data using the data explorer. And during the model training, there is a provision by which you can use the spot instances so that you can save up to 90% savings as well. And the main benefits, if you summarize, you can see like no upfront investment is required for starting custom model development. You pay only for what you actually use and when you use it. Also, automatic optimization is there. Resources scale up and down based on the demand. And there is no need for having dedicated ML infrastructure team, and which reduces overhead as well. The infrastructure management will be handled by AWS itself. So the customers who are already using this Sagemaker, based on the reports available from within the AWS documentation, they report faster time to market. Instead of month, they can deliver in weeks. Also, it increased developer productivity and reduced operational complexity. And because this is an unified platform, it eliminates the cost and also the learning curve and complexity of managing multiple separate tools. And once organizations get into the Sagemaker Studio, they see around 200 to 300% return of investment within 2 years through the faster innovation cycles and reduced infrastructure costs. Of course, this depends on other factors as well, but on a typical scenario, this will be the return of investments. And also, there is no vendor lock-in. Sagemaker works with your existing tools and skill. You can bring your TensorFlow, PyTorch, or SCI kit learning models directly. No rewriting is required. All the major machine language frameworks and algorithms are supported, including TensorFlow, PyTorch, Hugging Face, and also popular data science libraries like Pandas, NumPy, SCI learning. All these are available. And your existing code and workflows can also be imported because in the notebooks, the Jupyter notebooks, you can have everything from within. Now, we are looking into some of the expert insights and best practices to work with Amazon SageMaker. By default, the SageMaker offers you safe development environments. The design of the SageMaker tool is in such a way that it ensures your experiments and it never breaks the production systems. Because it's like having separate workshops for development testing and final deployment. So how this works is that during the custom model development, data scientists work in isolated development environments. They will be focusing on developing the best model. Then to test it, the models pass through staging environments before going live. And once it is ready to deploy, we could deploy that confidently because built-in quality gates prevent problematic models from reaching customers. There are different approaches are there to set this up, especially in SageMaker teams within an organization. We will be discussing two approaches mainly. One is within the, if you want to have an machine language custom model development or AI model development within your enterprise, one approach is like you can have separate AWS accounts for each teams with maximum isolation, and this is recommended for large organization. Even though your different teams will be having separate AWS accounts, whether it is a development, QA, production, data scientists. They are having separate AWS accounts, which provides maximum isolation. And this is the one recommended by large organizations, recommended for large organizations. And to consolidate or group it all together, AWS organization provides a way to group all these different teams together. Even though they are under different accounts, they can also combine in a unified way through AWS organization. And whenever one artifact is ready from one team, it can be go through the model registry, and then it can be handed over to other team. And also, like we discussed before, quality gates are there. That means you will be ensuring that model or the AI framework which you developed will be production ready before it goes to live. So this is one approach, having separate AWS account and then group it under AWS organization for maximum isolation. And this is the recommended one. Second one is if you don't want to complicate having too many accounts, you can also have separate environments within one account. That is having a dedicated VPC for each teams so that they can be isolated. And this is perfect for smaller teams as well. So where you use a kind of a separate AWS account or minimal AWS accounts, Sagemaker projects, fundamentally project is the concept in Sagemaker. So the Sagemaker projects provides pre-built templates that set up these safe development practices automatically. So no custom infrastructure is required actually. And also imagine you worked on such an custom model, everything went fine. You are now going to deploy that. And based on your needs, your organization needs, you can deploy anywhere, your models anywhere. And here is why Sagemaker really benefits for you. It offers the maximum deployment flexibility. Your trained models can go anywhere when your business needs them. So how can you deploy to using different approaches? One approach is like a real-time endpoints. So this is like an API, similar to what we discussed before in Amazon Bedrock. You can have an real-time endpoint as an API, which will be helpful for applications or auto scaling, which will provide instant predictions with auto scaling for applications like a fraud detection. Similarly, serverless inference endpoints also, option is also available, so that serverless means that the underlying burden of having multiple underlying serverless inference means that whenever your requirement comes to for inference through an API, sometimes the request will be too much heavy, especially during some peak time or during some content releases or during some specific days. So that time your infrastructure within the as Amazon SageMaker should scale automatically. That facility is already there. Serverless, which is called the serverless inference, that is also there, which scales to 0 when not in use and perfect for whenever the demand is high, and is also perfect for cost optimization. Other than this real-time endpoint, serverless inference, there are options for container deployment that gives you maximum portability. And that means the same model can run in SageMaker, or you can run that on Kubernetes, or in some compliance requirements, you want your custom model to be deployed on premises or sometimes on edge deployments as well. So whether it is SageMaker, where you want to try these models, or whether you want to provide this as a kind of an endpoint, or if you want to deploy that on specific platforms like Kubernetes or even on-premises or edge, SageMaker offers the options for that. That means that you can integrate with existing systems through API, connected to business intelligence tools, or even you can combine the other service which we discussed before, which is called the Amazon Bedrock for foundation model applications. The key is flexibility without vendor lock-in. The benefit of serverless is that you don't have to manage anything, and it offers the maximum benefit for you. So now the question happens like, which one should I choose if I develop a proper model? If your organization develop a proper model using the Sagemaker, should I choose the real-time serverless or container? And I feel it's worth to dive a little bit more deep, because this decision can help you to get started with which approach to choose as well. So one of the most critical decisions is this: choosing the right deployment approach. It's like you can think of this like selecting the right vehicle for different types of trips. And each option serves specific needs and use cases. The first one which we discussed, which is the real-time endpoints, or you can think of that as an always-on ML service. These are dedicated endpoints that's always ready to respond instantly. These are perfect when you need consistent, low latency predictions with predictable traffic patterns. This real-time endpoints way of deployment is suitable for high-frequency application like credit card fraud detection systems that needs processing thousands of transactions per minute. Also, user-facing applications like recommendation engines that need sub-milliseconds response time. Also, applications which have a consistent traffic or SLA requirements, or which requires a complex model that needs to be worked from memory. There, all these kinds of real-time endpoints are suitable. One of the real-world example is like the Amazon.com e-commerce sites itself. It uses real-time endpoints for their product recommendation engines that powers customers like who bought this item, and can provide based on that personalized homepage recommendations. And millions of customers will be browsing simultaneously. So they need instant recommendations that based on their user behavior in real time. And this kind of real-time endpoints using SageMaker is one such option. It's kind of a real-world example. And the cost consideration for this is that you pay for the instance even when it is not processing request. But you get predictable cost and guaranteed performance, and also auto-scaling in this real-time endpoints gets optimize the cost by adjusting capacity based on demand. So we discussed about the real-time endpoint, and next we are looking into the serverless inference deployment, which is kind of a cost-effective way, like a pay-per prediction efficiency. Serverless inference is like having an on-demand taxi for your machine language models. You only pay for when you are actually using it, and it automatically appears when needed. And when should we choose this serverless inference? It's suitable for like if you have an application which requires intermittent usage of this inference, like applications with unpredictable traffic. And you can use this serverless inference. Also, organizations which require cost optimization, like minimizing the infrastructure cost, then serverless inference will be a good choice for that. Then whenever you start working on custom model development, AI model or machine language model development using SageMaker, serverless inference model should be ideal for experimentation and staging environments. Also, batch like real time, like processing that happens in burst rather than on continuously. Serverless should be a good choice because you can have on demand scalability at that time. Also, use cases where you are having smaller models, then more, which can start in less than under 10 seconds. Serverless mode of inference will be a good one. And one of the real world example is that this is based on the documentation that is available within the AWS. One healthcare organization uses serverless inference for their Edison AI platform medical image capabilities. So what happens is radiologists upload medical images throughout the day, but usage varies dramatically across different time zones and hospital schedules. Sometimes they will be need processing hundreds of scans per hours. Sometimes none of them for a few hours. So here serverless inference can help because they can scale to zero during quiet periods, which can reduce the infrastructure cost by up to around 80% while still providing faster responses when medical professionals need immediate analysis. In serverless inference, you only pay for the compute time used during inference, plus a small request fee as well. That means for intermittent workloads, this can reduce the costs by 70 to 90% compared to the real-time endpoints like we discussed before. So real-time is suitable for predictable workloads, and serverless inference is suitable for unpredictable, where you will get the maximum cost optimization with maximum scalability. Then the final one which we are discussing is the container deployments, which offers the maximum flexibility and portability. Container deployments are like having a portable AI workshop or ML workshop that can set up anywhere, whether that is in Sagemaker, your own Kubernetes cluster, or even on-premises infrastructure. And when to choose this custom container-based SageMaker deployment is your organization will be having a kind of a multi-cloud strategy, and you would want to deploy the same model across different cloud providers. Then container deployment strategy should be suitable. Then another use case is like hybrid environments, where organization needs some workloads to be running on premises for compliance or latency reasons. They can choose this container deployment pattern. Similarly, some organizations have their existing infrastructure in Kubernetes, and they want to leverage their existing container orchestration investments rather than having a new one. So that time they can choose this container deployment strategy. Also, there are cases where there is a need for a custom deployment requirements, like need specific networking security or integration pattern. That time also the container mode of deployment will be suitable. Similarly, edge computing, organizations relying on edge computing, they will be need this deploying to edge locations. Based on the real world example case, the one that I found in the documentation is the Siemens, which uses the container deployments for their IoT platforms, predictive maintenance model across their global manufacturing operation. That means they deploy the same containerized models in AWS for their US-based facilities and in European factories. Especially, they will be using an on-premises mode of container deployment. This is for ensuring GDPR compliance and other data sovereignty requirements. Similarly, on edge devices in remote manufacturing locations with limited connectivity, they will be going with an edge container-based deployment. This means that container form of deployment using the AWS SageMaker enables consistent AI capabilities across different facilities worldwide while meeting local regulatory and operational requirements. Similarly, the deployment options for this can be if for container, you can have SageMaker multi-model endpoints, which hosts multiple models in container for cost efficiency. Similarly, the models can be also deployed onto Amazon Elastic Kubernetes services, which is a kind of a Kubernetes service available in Amazon. This can help to deploy to managed Kubernetes for enterprise-grade orchestration. Similarly, if you want to deploy a container model in a serverless fashion, AWS offers a service called AWS Fargate, where you get the benefit of container plus serverless without managing the underlying infrastructure. Similarly, organizations that already have an on-premise data centers, they can deploy the containers there or on the edge devices like we discussed before. Now, we will discuss more on this decision. I know that this will make the episode a bit lengthier, but this will give a good understanding about which mode of deployment should be chosen, because anyway the model development will be handled by the data scientist, and it will be based on the data that you feed onto the SageMaker. But the decision framework, like which one to choose the right approach and all, one part which we discussed, like should we choose the real-time, serverless or container mode, and to choose that, there are some other criteria also, like based on some of the different requirements or analysis, you can select a particular mode of deployment, like real-time, serverless or container. If you analyze the traffic pattern, if you have a consistent high volume traffic, then real-time endpoints should be the best one, like as we discussed before for the Amazon's case. Similarly, Amazon.com case, that's an e-commerce site. Then cases where you have unpredictable traffic, then there is no point in having an infrastructure up and running at all time. So serverless inference would be a good choice. And second thing is another on way is like where the organization needs multi-environment deployment, then they can go ahead with the container deployment. Then when you think from a latency requirements, if you need sub-milliseconds response times or inference response time, then real-time endpoints should be your way to go. And if you can tolerate a certain level of delay in the response, especially the inference response. So here the response part I mean is like your application will be having need some form of inference from these services. Basically, they will be connecting through a kind of API. So that time, if you can tolerate 1 to 10 seconds of milliseconds of 1 to 10 seconds of response, which is acceptable, or you can tolerate, your applications can tolerate, then serverless inference would be a good choice for that, which means you will get the benefit of scalability with a reduced management or reduced infrastructure management overhead. Then if you have other forms of latency requirements, like having an on-premise requirements, or if you have something which needs to be immediately accessible, like the case of on-premises, then container deployment will be a good choice for that. Now, coming to the operational complexity, if organization needs fully managed preferred, then real-time endpoints or serverless would be the good choice. And if they need a custom control or to meet certain regulatory guidelines or compliance and security, container deployments should be a good choice for that. If standard AWS security is sufficient, they can go either with serverless or real time. But if they need like a specific networking requirements or on-premises deployment, they will have to choose the container deployments. Similar, like I discussed before, there is no one-fit pattern suitable for all organization. Sometimes most successful organization use multiple deployment approaches for different use cases. One example would be like they will be using the real-time endpoints for critical paths and serverless for secondary features. Similarly, serverless, they use the serverless mode for development or testing and real-time for production. And they might use containers for global deployment, but real-time endpoints in primary region. There are different ways. So it's there is no one-fit rule for that. So the idea is SageMaker makes it easy to start with your whatever form of deployment or inference mode you want. The one ideal way is like you can start with the serverless inference for experimentation. Then if need, you can migrate to real-time endpoints as traffic grows. Then if you need multiple models to deploy on multiple targets or multiple cloud, then container form of deployment would be more choosable. The key insight is that the best organization choose their deployment strategy based on specific business requirements. Then they evolve their approach as needs change. SageMaker's flexibility ensures you are never locked into a single deployment pattern. Now, we can look into the MLOps pipelines, which is available within the AWS. Think of the MLOps as like your AI assembly line. The code commits automatically trigger SageMaker pipelines, which handle everything from data processing to model validation. Successful models get registered with built-in approval workflows, and the quality gates ensure only validated models reach your customers. The beauty here is the automation. Your models move seamlessly from development to staging to production through quality gates with complete traceability and enterprise-grade governance built in. Also, different model performance metrics, traffic predictions, cost optimization suggestions, blue-green deployment models, all are available within the SageMaker Studio FS. So the best practice for success is start simple. Start with the SageMaker's managed services and built-in algorithms that are available. So that way you can start. And this is better than building custom models from scratch or to develop a custom model on top of this algorithm. You can start with the existing built-in algorithm. Who knows, that will be a good choice for your organization. And use the SageMaker or AWS free tier and SageMaker Studio Lab to experiment and learn. And when having multiple resources, it is a good practice to tag proper. The benefit of tagging is that you can easily identify the related resources if it is using certain resources are used for the production environment. You should tag it with production, and for development or staging as like vice versa. And cost monitoring should be, and the observability should be have from day on to avoid surprises. Like I usually say in most of the other talks as well, like observability is not an afterthought. It should be there from day one, so that you will get a complete picture of how these different distributed models works behind the scenes. And if any issues happen, you can trace it very easily. Also, think about the security by design. Implement network isolation by using virtual private cloud and private subnets. use IAM roles with the least privilege access principles, and enable comprehensive logging and monitoring for audit trials. Use AWS KMS, Key Management Service, to encrypt all data in transit and at rest. Also, when multiple teams start working in the AWS Amazon SageMaker Studio, even though it's a kind of an unified environment, establish clear project structures and naming convention. SageMaker has its built-in collaboration features, so you don't have to depend on external tools. Implement proper version control for both code and data. Document your ML workflows and model decisions for future reference. The key insight is that SageMaker provides both the ML platform and the deployment infrastructure, creating a seamless experience from the experimentation to production. This integrated approach reduces complexity while maintaining the flexibility to deploy models wherever your business needs them. Now, we can look a bit more deep into the typical team workflow before we wind up, how each team will be working in the SageMaker Studio. Even though this is a unified environment, different members will be working on this SageMaker. And like we discussed, each member, each group may be having their own AWS account as well. But let's see collaboratively or collectively how this typical team workflow from idea to production. So this can be think of like a kind of a race where each team member hands off the control to other seamlessly. So let's the start will be the business analyst. They will be defining the problem. The business analysts identify opportunities where AI or machine learning can add value. Then using the SageMaker's Data Explorer query editor, they can explore the different data patterns and validate business hypotheses. They create data visualizations and share insights with the team through SageMaker's collaborative notebooks. So the key activities this team will be encountering is data exploration, business case development, success metric definitions, and they use the SageMaker tools like Query Editor, Data Wrangler, for visual data preparation. The next handover will be to the data engineer, whose responsibility is to prepare the foundation. They build robust data pipelines using SageMaker's processing jobs and feature store. They ensure data quality, implement data governance policies, and create reusable feature engineering workflows. Once it is available in the feature store, that feature store becomes the single source of truth for ML features across all projects. Then the next handover is to data scientist, whose responsibility is to build an experiment. Data scientists normally use SageMaker Studio notebooks for experimentation and model development. For this, they leverage the built-in algorithms which are available within the SageMaker. Sometimes they bring custom frameworks like TensorFlow or PyTorch. Whenever they do or experiment, SageMaker automatically tracks all their trials, making it easy to compare different approaches. Some of the tools they will be using during this stage will be Studio notebooks. Studio in the sense, SageMaker Studio. Then experiments. They could enable automatic model tuning, they can use built-in algorithms. Next, the step is to hand over to the machine ML engineer, whose responsibility is how to optimize and scale these. So once they get the promising models from data scientists, the ML engineer's role is to take those models and optimize them for production. They use Sagemaker training jobs for distributor training, implement model monitoring, and set up automated retraining pipelines. Also, the inbuilt model registry that is available within the Sagemaker helps with the proper versioning and approval workflows. And after that, it's hand over to the DevOps engineer, whose responsibility is to deploy and set the infrastructure. So DevOps engineer manages the deployment infrastructure using Sagemaker endpoints and integrate with existing CI/CD pipeline. They will be implementing the blue-green deployment, set up monitoring and alerts, and ensure security compliance across all environments. And then the application developer. So once this model is available as a kind of a way for the applications, like it could be like the in a kind of a serverless fashion, or maybe in a container mode, or it can be a real-time endpoint as well. Those all things which we discussed before. So once the DevOps engineer sets the deployment mode and infrastructure, either of in this way which we discussed before, that model will be ready to use by the applications. Now the role is for the application engineer. So the team will be informing the application engineer that integrate this endpoint where you can this model and all. Just like the applications use the managed Amazon Bedrock, similar way the applications can use the Sagemaker endpoints. So they integrate the ML predictions into business applications using their REST API that is called the endpoint. They implement caching strategies, handle error scenarios, and ensure smooth user experiences. And real-time and batch inference options provide flexibility for different use cases. And finally, the operations team, whose role is to monitor and maintain the applications which are using these models. And they model the model performance based on how the applications are actually using it. They identify the data drift and system health using Sagemaker model monitoring and also the CloudWatch logs. They also manage costs through automatic scaling and spot instances, and coordinate model updates and rollbacks when needed. So the complete workflow summary will be like, it's starting with the business analyst. They define the business problem and they start with the data exploration. Then the data engineering team, whose role is to create the data pipeline and feature engineering. And then the data scientist, and they use the studio notebooks, they experiment and they auto-tune the model. Then the ML engineers, whose role is to optimize the model and pipeline automation. Finally, the DevOps, it is handed over to DevOps engineer, who set up the production deployment and infrastructure setup, endpoints and so on, and hand over to the application developer, who will be integrating these endpoints and with their applications and enrich the user experience. And to ensure that everything is going fine, the ongoing monitoring and maintenance will be set up, and operations teams will be doing that. They model them. They monitor the model. Also, they constantly monitoring the CloudWatch logs. Also, they will be using the spot instances or something as required so that they can optimize the cost. So in this way, collaboration plays a key role in Amazon SageMaker. Everyone works in the same SageMaker environment with a shared projects and notebooks. Version control is built in for both code and models. Automated handoffs between stages reduce manual error. Complete audit trials satisfy compliance requirements. Real-time collaboration features faster iteration cycles. Now, sometimes, depending on the need, some organization use the inbuilt SageMaker options itself, and they don't need a separate cloud formation, unless if they want to do something custom. Because SageMaker has all the different options, whether for experimenting, developing, team structure, everything it is there within the SageMaker itself. But still, CloudFormation are valuable when they need to integrate with existing AWS infrastructure, when they have specific networking requirements, or multi-service architectures beyond the SageMaker scope. The main insight is that the SageMaker native automation eliminates most of the infrastructure complexity that traditionally required custom templates. Now they can let go all of those and they can focus on the model development. Now, some of the patterns also, I think it's worth to discuss, like the AI success patterns, how companies actually use SageMaker. So this is the final part of this episode, and then we can wind it up. We will see some of the common ways successful companies organize their machine language or AI projects. This can be think of like some kind of a recipe that you can follow for your own AI initiatives as well. One is the assembly line approach or automated model factory. So this can be think of like as a car factory that has standardized steps to build every car. Same way, you can create a standardized process to build and deploy every model. And for this, SageMaker can help you with the pipelines, which can handle automatic data preparation, model training, testing, and deployment. Once set up, new models follow the same quality control process. One of the real use case for this is Netflix. They use this approach to create hundreds of recommendation models for different regions and content types. Their automated pipeline ensures every model meets quality standards before reaching customers, enabling them to personalize experiences for around 230 plus million subscribers worldwide. Another pattern for machine language is champion versus challenger. It's kind of an improvement pattern. Okay. It's like having a base model which is called as champion, and new models like challengers to see which performs better with the real customers. So new models can be developed using this champion versus challenger model. And how SageMaker can help with this is once the models are developed and ready to deploy, SageMaker automatically sends a small percentage of traffic to new models, while the majority goes to your existing, that is the proven model. Then, based on how the new model performs, then that can be switched off. And one of the real world use cases, Airbnb uses this pattern for their pricing recommendation engine. They continuously test new pricing models against their current champion, automatically promoting better models that help hosts optimize their earnings while maintaining high booking rates. This is similar to the way by which when we use the Copilot or Amazon Q, we select the different models. Same way we identify the better champions and promoting them, better challenges and promoting them. Then another proven pattern is the shared knowledge base or the feature store. So the idea of this pattern is that instead of every team recreating the same data calculations, they create a shared library of pre-calculated insights that everyone can use. And Sagemaker offers a feature called Feature Store. The name itself is Feature Store, that acts like a shared database where teams store commonly used data features like customer purchase history or seasonal trends that multiple AI models can reuse. And when it comes to the real-world customer example, DoorDash, they built a centralized feature store containing customer behavior patterns, restaurant performance metrics, and delivery logistics data. This allows their fraud detection, recommendation, and delivery optimization teams to share the same high-quality data features, reducing development time by 60%. Then the other pattern is cloud to edge pipeline or AI everywhere. The idea here is to train the AI models in the powerful cloud, then deploy the smaller versions to devices like smartphones, cameras, or factory equipment for instant responses. And Sagemaker offers the full power for training this model. And there is a tool within the Sagemaker which is called Sagemaker Edge Manager, which deploys optimized versions to edge devices that work even without an internet connection. And the example of this is Philips Healthcare. They train medical imaging AI models in AWS using Sagemaker, then deploys them to MRI and CT machines in hospitals worldwide. This enables real-time image analysis during procedures, even in locations with limited internet connectivity. Then the final approach or the pattern which we are going to discuss is cost-smart approach or multi-model hosting. Instead of having separate servers for each AI model, which is actually expensive, hosting multiple models on shared servers that automatically load the right model whenever they need it. Sagemaker offers an option called multi-model endpoints that automatically manage multiple models on shared infrastructure, loading them on demand and scaling based on usage. Intuit, an organization, they host over 1,000 different tax and financial models on shared Sagemaker infrastructure. And during the tax season, tax-related models get more resources automatically, while other models scale down, optimizing cost while maintaining the performance. So the key takeaway for all these different patterns that which we discussed are, these aren't complex technical concepts. They are practical business strategies which can help to solve the real problems, reduce cost, improving quality, speeding up development, and also ensures the reliability. So the future is now. To wrap up, Amazon Sagemaker isn't just a machine learning platform. It's your complete AI transformation partner. Whether it's about starting data exploration to production deployment for custom model, or from individual experiments to enterprise scale operation, Sagemaker with your ambitions. So whether your organization needs to detect fraud, personalized customer experience, or predicting some form of a recommendations or equipment failure, Sagemaker provides the foundation you need to turn AI possibilities into business realities. Now, like as I discussed in the start of the episode, if you want your applications to use some existing pre-foundation models, you can have a check with the Amazon Bedrock service, which is an kind of a on-demand managed AI service available from Amazon from the AWS. You can find that in the console, which offers a kind of an API where you can where your applications can interact with the AI, different models, and you can switch the model, you can inference the model, and so on. A lot of additional features is added onto Amazon Bedrock so that you can give your organization context in the form of retrieval augmented generation, which is called the RAG. Similarly, if you want to have some agentic AI workflows in your organization, it will be worth to check the STRANDS framework, STRANDS, which is a framework which can help with the easier development of agentic AI models. So the concept of generative AI is that it can generate new text, and agentic AI goes a bit further, that it can understand your prompt, it can have multiple agents or multiple tasks to achieve your requirements, and it can also iteratively improve based on the outcome of those tasks, so that until whatever you mentioned in these tasks in the prompt is achieved, it can iteratively work. So that is agentic AI, and if you want to develop an agentic AI application, STRANDS framework will be the best one. It's a Python-based framework, and once you have that, you can host that on container platforms, or you can host that on Agent Runtime Core, which is another new service available. Then the role of the Sagemaker is more about deep custom training models, where you need a platform, entire platform, where every member of your team can collaboratively work to develop a custom model. The Sagemaker provides the different algorithms and tools for that, and plenty of tools and connectors that can help you to collect the data. You can deploy the data. It offers different deployment models, and it's a kind of a complete platform. So with that, we wrap up this podcast for today. The Malayalam version of this podcast will also be available on a different podcast, which is called Coding Talks with Vishnu Malayalam, where regional listeners can listen to that. So thanks for tuning into that. Have a great day.